The LSP Application Manager is designed as a bootloader for loading, starting, and stopping Lua server pages applications in a running system. In this presentation, we will show you how to use the LSP Application Manager as a tool during development for loading and managing LSP applications. The LSP Application Manager is designed such that it works in any environment, including embedded systems without a file system. We will first show you how to use the LSP Application Manager on a PC by using the disk I/O for loading auxiliary LSP applications, and then later show you how to use the LSP Application Manager in an embedded device without a file system. The Net I/O is a file server client designed to interface to the web file server running on a host computer. The Net I/O speeds up the development time in embedded systems since the file server allows you to do active development in a device while leaving all LSP files on the PC. The Net I/O client fetches the files from your host computer by connecting to a web file server on your host computer. In this case, the host computer is my PC. Let's go ahead and start the LSP Application Manager on a PC. We can now enter the address to the PC where the LSP Application Manager is running in a browser window and browse to the LSP Application Manager's graphical user interface. I can either type in the path directly to the application or I can browse to the location. I have now selected the same application that we created in the web file server video presentation. The application name is used as an application's base URL. We have now registered the application, but the application is not running. Notice how the application automatically positioned us at the Application List tab. Active applications are shown in the left column. As you can see, this is the LSP application we designed in the web file server video presentation. Let's simulate a system restart by restarting the LSP Application Manager. The restarted LSP Application Manager does not know about the application we previously registered. When I enter the address to the LSP Application Manager using the browser where the cookie is stored, the LSP Application Manager extracts the cookie data from the browser and uses the data to load the configuration file. The LSP Application Manager then analyzes the configuration file and loads any LSP applications in the configuration file that was tagged as running. This operation may take some time if you have many applications registered as active in the configuration file and if you are using the Net I/O. Since we are using the local file system, the operation is lightning fast. You can see that the LSP application we registered before restarting the server is loaded and active. I have now integrated the LSP Application Manager into the firmware of an embedded device without a file system. Let's type in the IP address of the device with the integrated LSP Application Manager. We can only select the Net I/O since the LSP Application Manager is compiled for a device without a file system. In other words, we cannot use the disk I/O. We recommend using the Net I/O even if you have a file system in the embedded device, as the Net I/O makes it possible for you to keep all files on the host computer during development. We must start the file server on our host computer before we can use the Net I/O network file server client in the embedded device. Let's browse to the web file server running on my PC. We can change localhost to the IP address of my PC. We should see the same interface. We introduced the web file server in the web file server video presentation and showed how one could use this tool for loading auxiliary LSP applications. We will now show you how to use the file server functionality integrated into the server. What you now see is a web file manager. The web file server integrates 3 file servers into the same URL. A web file manager that can be used by browsers, a WebDAV server that can be used by WebDAV clients, and a Net I/O server that can be used by Net I/O instances connecting from an embedded device. I will copy the URL to the file server and use the URL to configure the Net I/O client in an embedded device. I use the same base URL for browsing LSP applications on my PC. The LSP application on my PC is registered in the embedded device by clicking the Submit button. The application is now configured but not loaded. Let's go ahead and load the application from the PC. The application is now running and the link to the application is shown in the left-hand column. The benefit to using the NetIO during development in an embedded device is that you can keep all files on your PC during development. When you change the file, the NetIO will automatically load the new version directly from your PC into the embedded device when you press a refresh button in your browser. The following diagram from the LSP Application Manager documentation illustrates how the NetIO fetches data from a file server running on another computer. For more information about the LSP Application Manager and this diagram, browse to our online documentation and navigate to C and C++, Examples, and finally the LSP Application Manager.